Objective and use case. What you'll build: a practical FPGA-based GPS monitor using the Radiona ULX3S, Lattice ECP5-85F, a u-blox NEO6M GPS module, and 3.3 volts UART wiring. It will receive NMEA data at 9600 baud, parse time and position sentences with sub-second update latency, and display UART activity, fixed status, and key state changes on the ULX3S LEDs. Why it matters divided by use cases. GPS module bench verification. Quickly confirm a NEO6M is powered, transmitting valid NMEA sentences, and responding at 9600 baud without opening a PC serial terminal. Portable installation diagnostics. Use USB power to check fixed progress, live UART traffic, and changing coordinates in the field before attaching the final host system. Typical visible status refresh is 1 Hz, in line with common NMEA output. Digital design training. Demonstrates real FPGA handling of asynchronous UART reception, ASCII stream parsing, and sentence validation instead of a simple loopback demo. Standalone serial monitor prototype. Creates a compact GPS NMEA position time monitor for timing, tracker, and navigation bring-up with very low FPGA load, typically well under 5% logic and effectively 0% GPU usage. Audience: FPGA learners, embedded developers, and technicians validating GPS hardware. Level: beginner to intermediate.
Would you like to really get electronics, computer science, and AI without drowning in endless theory? At Prometeo.blog, you learn by actually building and coding. Every week, we publish concise micro-tutorials, technical comparisons, and product overviews to help you decide what to buy and how to use it. But the real gem is our practical cases. Very detailed guides that take you from the bill of materials all the way to final validation. You'll design and test circuits with analog components like resistors, diodes, transistors, capacitors, inductors, relays, and transformers, and with digital logic like AND, OR, NOT, NAND gates, etc. You'll build projects with FPGA, Raspberry Pi, Arduino, ESP32 or Jetson, and even the UGV robot. Everything is step-by-step, exact commands, ready-to-run code, wiring guides, real electrical schematics, SPICE net lists with real simulation plots, troubleshooting guides, upgrades, and much more. All our posts are available in both Spanish and English. At the end of each article, you'll find a short quiz so you can quickly check what you've learned. You also get your own private Prometeo ChatGPT tutor, specialized in electronics, computer science, and AI, with precise knowledge of all the content on the blog. Point. If you really want to learn by doing, advancing one project at a time. Head over to Prometeo.blog and get started today.